We're going to continue to look at solving quadratics. Now, we looked at solving quadratics by graphing to see where your parabola crosses the x-axis. Sometimes we got exact answers, sometimes we only got approximations. Now, factoring allowed us to always get an exact answer, but not everything factors. So we're going to look at a method called completing the square. Completing the square always works to solve a quadratic. So here are your steps for solving a completing the square. You want to do step one, get the variables on one side by themselves by taking the constant to the other side. So you have to add or subtract it to get it away to get it to the other side. You can only complete the square if your squared term is 1. So if needed, if you have something other than 1 in front of your squared term, you have to divide everything by a. Once again, that's dividing everything on both sides. Then you add a blank spot at the end on each side, and then we go half of b squared, and that's what we add to both sides. Then you factor the left side, and then you finish solving it. So let's go through that on a couple of problems. Step one, we got to get the squared or the variables on one side by themselves. So that means we got to get rid of our 55. So I'll subtract a 55 from both sides. P squared minus 16p is equal to minus 55. Now, you will notice that here we don't necessarily have to do this step because our squared term, what's in front of our squared term, is already 1. So we can skip that step, and then we can just move on to this. So we're going to add blank spots to each side. Then we have to do half of b squared. So 1/2 of b, so that's 1/2, your b is this right here. And half of that is 8. So we're going to add a half of 8 squared, it says, to both sides. So here on the left, this is going to then factor into two identical parentheses. You could do that AC factoring there. And then on the right, we add these together. Negative 55 plus 8 squared, and that's 9. So on the left, the easiest way to write that is a p minus 8 all squared is equal to 9. Now all we have to do to try to finish solving this, since we have something squared, is undo that by taking the square root of both sides. Now remember, when you take the square root of both sides of an equation, it's plus or minus. Now p minus 8, remember the square root of 9 is 3. So then to get p by itself, I have to go ahead and add 8 to both sides. Now, since these are both nice, neat numbers, I need to break it apart into the p plus 3, and then I have to look at my other answer, and that's the p minus 3. Well, 8 minus 3. So the 8 plus 3 is 11. If I do my 8 minus 3, I get 5. So I get my two answers of 11 and 5. Now this is one where we could have factored it. But let's go through the process on a problem where it would not have factored. Because you could try to do AC factoring here, but you will not find anything for your A times your negative C that would multiply together to give you negative 79, that would add together to give you that negative 2. So completing the square is the only way to do this. So you do your first step. You got to get your variables on one side by themselves. So you'd have to add 79 to both sides. Here, you got to get the number in front of your squared term to be 1. Well, it's already 1, so we don't have to do that step. So then we can go ahead and add a blank spot to both sides. And then we have to do half of b squared. So b is our 2. If you do half of 2, that's 1. So I'm going to go 1, and then I have to square that, it says. Whatever you have for b, half of it and squared. Well, I'm going to add 1 squared here. So on the left side, when you do your AC factoring, you're going to get an m minus 1 and a second m minus 1. On the right side, we can work that out. We get 80. So on the left side, since both parentheses are the same, and when you're completing the square, they should always factor into the same thing, we're going to get this. Well, then all we have to do is take the square root of both sides. Remember, plus or minus, and we get the square root of 80. Now, remember, we need to simplify roots just like we've done in the past. So I'm going to take a look at 80 and I'm going to do a factor tree. And so we can see we have a pair here and we have a second pair here. So I can go ahead and rewrite 80 as a 2 squared, a second 2 squared because we have a second pair, and a 5. Now your square root undoes each one of those squarings. So we're going to get a 2 in front times another 2 in front. I can't do anything with that root 5. So in other words, it gives us a 4 root 5 when we simplify. So then to get m by itself, we have to go ahead and add 1 and add 1. So we get m is equal to a 1. Now our 1 cannot go with that 4 because that 4 has a root 5 attached to it. So it's just going to be 1. And then we're going to go plus or minus a 4 root 5. Now, if after our plus or minus it was a nice neat number like it was in the last time, instead of a root, you could break it apart and write it as 2 separate ones. I'm going to just go ahead and leave it like this. So let's just continue to practice completing the square. So to get your variables by themselves, we have to go ahead and subtract 13 from both sides. And then we have to go ahead and get the number in front of your squared term to be 1. Here we have it timesing by 5, so we have to divide everything by 5. And so we get a k squared plus a 2k. We can add those blank spots. Minus 13 over 5 plus a blank spot. Then we have to do half of b. Now b is this right here. It's not your original b, it's your b once you get your a to be 1. So we have to do half of 2, which is a 1, and then we have to square that. And that's what we add to both sides. Now the left side's going to go ahead and factor into a k plus 1 and a second k plus 1, so I can write it as a k plus 1 all squared. On the right side, I add these together and I get a negative 8 over 5. It's going to be beneficial to write these on the right side as a fraction if they're not nice, neat numbers. Well, then all we have to do is go ahead and get k by itself by undoing my squaring by taking the square root. Remember, plus or minus. And then you can do the square root of the top over the square root of the bottom. And now we're going to have to just simplify the right-hand side like we've done before in earlier chapters. Now, remember, the square root of a negative is always going to give you an I. The square root of 8, remember, 8 is a 2 squared times a 2. So you can pull that squared term out of your root, and you get a 2 in front with your I. And then this second 2, which is to the first power, you can't do anything with, over our root 5. Now, remember, we can't leave a root in the bottom, so we're going to multiply by a special form of 1, which in this case is root 5 over root 5. Because when you multiply out the bottom, a root 5 times another root 5 would be the square root of a 5 squared. But remember, your square root and your squaring undo each other, and so we just get a normal 5 in the bottom. And then we can go ahead and multiply out the top of our fractions. We'd have a 2i, then multiply what's in front side your roots, the 2 times the 5, and that's equal to our k plus 1. Since we have an I here, that means if we did graph it, our parabola would either be totally above the x-axis or totally below the x-axis. Since we had a positive in front of your squared term, we know it's a parabola opening up. So this one, if you graphed it, would be a parabola always above the x-axis, never touching it. Then to finish getting k by itself, we would need to subtract a 1 from both sides. So we get k is equal to a minus 1 plus or minus a 2i root 10 over 5. So we'll look at one more here, completing the square. So we'll go ahead and add our 68 to both sides. So we get a 72 over here. We don't have to worry about the second step because the number in front of our squared term is 1. So we're going to go ahead and add a blank spot to each side. Then we have to do this half of b squared. 1/2 of b. Now b is 9, which ends up being just 9 over 2. So I can go 9 over 2 all squared. Now on the right side, I'm going to actually work out what the top is and work out the bottom. On the left side, I like to leave it like I have in blue because it's going to factor into an n plus 9 over 2 and a second n plus 9 over 2. What you put at the end of each parenthesis is what was in your parentheses squared. So you can write the left side as an n plus 9 over 2 all squared. Plug the right side into your handy dandy calculator and you end up getting 369 over 4. So then to get your undo your squaring, you can go ahead and do the square root of both sides. Remember, plus or minus, it'd be the square root of the top over the square root of the bottom. Square root of 4 is nice, neat, just 2. Well, we got to simplify that root on top, 369. Have to do a factor tree. It's not even, so 2 doesn't go in there, but 3 does. 3 goes in there 123 times. 3 goes in there a second time. And so you can see you have a 3 squared here that you can pull out. So on the right side, you can pull out that 3 squared, which is just the square root of 3 squared is a 3. You'd still have this left inside over your 2. And that's equal to our n plus 9 over 2. So now to get n by itself, we have to subtract that 9 over 2 from both sides. Now on the right side, that red 9 over 2 doesn't have any roots with it, so we cannot combine it with the black. So it needs to stay as negative 9 over 2 plus or minus what we had over there, because they're not like terms. And that would be our answer. So here, for the most part, you're going to do the reverse process of your factoring. Basically, it's like the game show Jeopardy, where you're given the answer, you got to work backwards through the question. So we're ending up with our final answers being this or this. Now, if you're solving by factoring, the second to last step you'd have would be something equals 0. So instead of having negative 4 on that side, I'd have to add a 4 to both sides. So this is what we would have. You'd have to do the same thing here. You'd have to get that 7 to be 0, so subtract a 7 from both sides. Now, these two things that are equal to 0 are the two things you put in parentheses that you multiply together to give you your quadratic. Now, just know that it says integers. So if these were fractions, you'd have to get rid of any fractions down here in this red line by multiplying both sides by your denominator. We didn't have that here, so we didn't have to be concerned about that. Now, we need to get our answer to be in this form here. Has to be equal to 0. It says quadratic equation. It has to equal 0 here. You'll also notice we don't have parentheses, so we just have to multiply this out on the left side. Multiply your first terms, x times x is x squared. Your outer terms, minus 7x, inner terms, plus 4x is a minus 3x. Multiply your last terms, and we get 28, and then it's equal to 0, and that's what we're looking for.